Okay, hello. So about 5.5 years ago, I joined Facebook. I left my job on Wall Street and went out to join Facebook. At the time, they had a few megabytes of data to understand user behavior, and I was the only research scientist at the company. When I left 2.5 years later, we were managing a few petabytes of data. So we had grown by about 9 orders of magnitude in the amount of data under management, and we had about 30 people in a group we called the data team. These 30 people were divided about half into those building the infrastructure to allow us to collect and analyze this data, and about half were the people devoted to analyzing the data and deriving meaning and impacting the business. So I thought we did some interesting things on both halves of the group, which I'd like to tell you about. For the infrastructure, both the software and hardware infrastructure was fairly novel. We began by building out a standard data warehouse business intelligence infrastructure. Now, these kinds of infrastructures are very good at managing structured data, but unfortunately, they don't scale very well. And they didn't incorporate a lot of the recent innovations in managing large data sets, which had happened at places like Google, where they had taken folks with an operating systems background and applied them to search problems. So we went out, and as our databases were breaking down, we went and we took a look at what they were doing at places like Google, and we also noticed that there was an open source project called Apache Hadoop that had been started by a few folks named Doug Cutting and Mike Caffarella to implement their ideas. So we brought that technology into our data centers, and we were able to use that to scale effectively up to multiple petabytes. Now, the interesting thing about this technology is, number one, that it scales to a much larger size than available business intelligence infrastructures. Number two, that it can handle more complex data types than existing business intelligence infrastructures. And number three, that it enabled more complex analyses to be performed against the data by folks with engineering backgrounds rather than just data analysts. But the most interesting thing about it was that it was open source, from my perspective, and that it ran on commodity hardware. So Apache Hadoop is essentially the Linux of data management these days. It's one of the most active open source projects out there, well over 500 contributors last year. And we really, we went, and when I left Facebook, started a company called Cloudera to help commercialize this technology and really drive it into the enterprise infrastructure similar to Linux. And then since I've left Facebook, they also started a project called the Open Compute Project to take that commodity infrastructure that we built with data centers and hardware and make that open source as well. So they now put all of their data center and server designs into the public domain, and a variety of vendors contribute to that. So it's open source infrastructure for managing data at very large scales, for doing data analysis and business intelligence. So we found that to be very exciting. And then the second half, the people that we had analyzing that data and deriving meaning, we thought we made a few innovations there as well. So we found that folks that we were hiring who had statistics and machine learning degrees weren't able to contribute right away to the work we were doing at Facebook. And in fact, the places where we were finding the best people, they were often highly technical social scientists because they tended to understand the whole research cycle. They knew how to instrument, collect, integrate, cleanse, model, validate, and present their results. They didn't just focus in on the modeling piece, as folks were often doing who were coming out of the machine learning space. So we started to create a curriculum for training these people, and eventually I took that curriculum and encoded it into a course that I taught earlier this year at University of California, Berkeley, called Introduction to Data Science. And so we tried to take some of the skills that we felt were lacking in the current undergraduate university curriculum, including data collection and integration, chart design, and more importantly, dashboard design for data visualization, experimentation at scale, causal inference and observational studies, and then the fifth unit in the course was building data products. So what does it feel like to actually deploy and operate a data product? So we created a new curriculum to train these folks, and the term data scientist that we created by just mashing up the title of research scientist with data analyst has really taken on a life of its own.